Okay, so what we're going to do right now is we're going to solve um, a system of equations. A system of linear equations, or a system of equations in general, is just more than one equation. A system of linear equation means both of the equations have to be linear, which is the type of equations we've been working with. There are uh, three ways of solving these that are generally used. One of them is generally called elimination. One is substitution, and one is by graphing. So we're going to be using the graphing method today. So first of all, when we talk about solving a system of equations, what we're looking for, what we're trying to do is try to find a value for both of the variables that works in both equations at the same time. So what I mean by that is if we look at one of the equations at a time, let's say, we can find a value for x and a value for y that works in that. But just because it works in one equation doesn't mean it will automatically work in the other. So one way that you can keep track of values is by making a table. So if we look at this first one and we say, okay, what happens if x is 0? What's y? So you would take 0 and plug it in for x. So we have something like this. 0 plus 2y equals 4. That becomes 2y equals 4. Divide both sides by 2, and you get y equals 2. Okay, so now we know that for this one, 0, 2 is a solution. So when x is 0, y is 2, it makes this a true statement. Now if we look at the other equation, which is y equals 3x over 2, we can use the same value for x, or we can use a different one, but we might as well use the same value. So when we plug in x equals 0, we get 3 times 0 divided by 2, 0 minus 2, y equals negative 2. So here you see it's 0, 2, x is 0, y is 2. Here we have 0 and negative 2. So they look almost the same, but one's positive, one's negative. They're completely different numbers. So we didn't get the same exact numbers for both x and y. So we could continue trying to get numbers, and we might guess the correct combination by accident or just pure luck. But it's not very practical to do it that way. So we need a different method that's going to give us the answer every time. One way of doing that is by graphing it. So what we'll do, the whole idea behind solving solving a system of equations by graphing is you'll take two different equations and you'll graph them. And when you graph them, you'll see they cross at a certain point. That point right there will be your answer. It'll give you a value for x and a value for y. So the way that's going to work here is we're going to graph this one, and then we're going to graph that one as well. Sometimes you will need to, this is in standard form, and there are ways of graphing in standard form, but right now we're just graphing them and using slope-intercept form. So the first thing you have to do is convert that to slope-intercept form. We want to get the y all by itself, so we subtract x from both sides. We get 2y equals negative x plus 4, and that's not in slope-intercept form until we have y isolated. We divide everything on this side by 2. This becomes y equals x over 2, and I'm going to write that as negative 1/2 over 2 plus 2. So that's one equation. The other equation is right here. Y equals 3 over 2 x minus 2. So these are the two equations, the first equation, the second equation. And so now the whole idea is to graph them. So you'll graph both of the equations. You'll graph them both on the same coordinate grid. So just like before, nothing different when you're graphing these. You label the x and the y axis. Put in your scale. And then we start graphing. So for the first one, you want to identify the slope. Now remember, you look for the x coordinate, the x variable, right? The x, the coefficient of x, the number in front, that's going to be your slope. So it's -1 over 2. So that means since it's a -1, we're going to go down. That's positive still, so we're going to go over. So if the rise is negative, the run is going to be positive still. Y-intercept is 2. Remember, that's going to be 0, 2. So I can graph that first line, and it'll look like this. We'll go up 2, make a point. Then from that point, we're going to go down 1 over 2, and make your line, just like that. Okay. Now the second one, and you could identify these if you want with a little 1. So the slope of the first one, y-intercept of the first one. Here we have the slope of the second one. Now the slope of the second one, this is our x. We look for the coefficient of x. It's 3 over 2. So it's 3 over 2. Both of these are positive, so that's going to be rise is 3, run is 2. And I just dropped my pen. Okay. So now we want our y-intercept, and our y-intercept is going to be the constant term right here, -2, and that point will be 0, -2. So we're going to begin with our y-intercept, just like we did the first one. So that's down 2, and make your point. Then we're going to go up 3 and over 2, or over 2, up 3. Now in this case, it meets right there. Okay, and this point, if we look at it, over 2, up 1, that's 2, 1. So 2, 1 would be our answer. In other words, our x coordinate is 2, so x is equal to 2, y equals 1. So what that's telling us, oops, let me write it correctly. So x equals 2, y is equal to 1. So what that's telling us is that if we plug in 2 into this equation, we should end up with 1 for y. If we plug 2 into this equation, we should end up with 1 for y also. The x's and the y's will both be 2 and 1 in both cases. And we can test that. So if we say, you can test it by plugging them in, replacing y with 1 and x with 2, and then checking to see if it's true. Or you can just plug in the 2, and that's the way I'm going to do it right now. So we have -1/2 times 2 plus 2. So -1/2 times 2, that's going to give you -1 plus 2, y equals 1. So we started with 2 for x. We ended up with y. So when x is 2, y is 1. That's what we get for this first one. The second one, we can do the same thing. 3 over 2 times 2, and then this one is -2. So now when we multiply here, 2 times 3 is 6, divided by 2 gives us 3. 3 minus 2